Welcome everyone. So this is our 29th live stream geometry and counting. So if you'd like to join these sessions, feel free to email me at mgreenb801@gmail.com. They're on Sundays at 10 a.m. U.S. Central Time. So we have three people here with us so far, and today I'm going to go over the problems from the China Girls Math Olympiad. So there's a couple different girls contests across the world. China has a math Olympiad for girls. Europe has one. That might be the most famous one. And then the UK and Brazil have ones. And for the China's Girls Math Olympiad, sometimes they'll also have girls from the US or Russia compete. So with that, I will get started. So let me share my screen. All right, so here is the first problem. I kind of try to put them in order of difficulty, but it's not exact. All right, so we have a triangle ABC that's acute, and AB is greater than AC, so I'm going to want to draw it something like this. O is the circumcenter. And B is the midpoint of BC. So label O as the center. There we go. And whoops, D is the midpoint of BC. There we go. Maybe make O and D a little farther apart. The circle with diameter AB meets AB and AC at 2 points, E and F. All right, so let me draw that circle. So I mean, that's obviously where the feet of the altitudes from D meet AB and AC, but I'm just going to label it anyway. So I'll call this point G. And I don't even know if there's really a point in drawing that circle, but it meets AB at E and AC at F. So DE and DF are perpendicular. You know what? I'm going to erase that, just because I think it's clear that there should be perpendicular. Oh, maybe it's well known. The line passing through D. Oh, I think I did solve this one. This one was previously on my channel. You're right. So I'm just going to type it up quickly and then move on to the next one. So the line passing through D parallel to AO meets EF at M, and we want to show M is the midpoint of EF. Yeah, sorry, I didn't look over these problems super long, but no, you're right. And I solved it. I think I used like what's called like a Varignon parallelogram. So if you take the midpoints of DE and CF, you get like a parallelogram. So yeah, this is kind of a good refresher, but yeah, I think I've solved this one pretty quickly. So yeah, Varignon. So I'm going to label the midpoints of DE and CF. I think this is how it works. And then MHDI is a parallelogram. So let's see, how does that solve it? I think what I did was I let M prime be the midpoint of EF, and then I show that M is equal to M prime because this is a parallelogram. Let's see what that does. So yeah, I think it might just be like an angle chase because, yeah, I have to use that these are right angles, but that's a parallelogram. And so is there an obvious way to show from that MB is parallel to AO? So I guess So I guess I can try to show angle M prime DA is equal to angle OAB. Actually, yeah, do you guys remember how to do this? I could just watch it, but yeah, I'm trying to remember in my head. Give me a moment. So yeah, we know. Oh, I think the angle between OA and we could try to show the angle between OA and EF is the angle between MD and EF, right? So I see someone else join. Hey, Ram, thanks for joining us. So we're doing the China Girls Math Olympiad, and this problem I already did it before on my channel, but I'm trying to remember how I did it. So without looking at the link. Yeah, ads do pop up on my videos. I don't know if once your channel gets to a certain size that starts happening, but yeah, I've seen that a bunch of times. Let's see. So I wonder if do AM prime and O, no, they don't meet on the circle. But this is a parallelogram. And I think we can show, let's see. So the angle between MD and EF, or M prime D and EF, how do we calculate that? So do you guys remember how to do this? I'm blanking a little bit here. Just drop perpendiculars from B and C. Okay. B and C to what? To what? To the like this, or yeah, okay. And then AO passes through it, right? So basically AO and J are collinear. And then how does that show that MD is parallel? Oh, from B to AC and C to AB. Okay. Really? Oh, so oh, well, I don't think it was the Varignon parallelogram I was necessarily thinking of. So, oh, J lies on AO because angle ABJ was 90, so AJ is a diameter. So yeah, I just erased that. No, it's all good. So I'm doing what Hakan said. So BE is EJ and CF is FK. And so I think if I take the midpoint of JK, then LEDF is a parallelogram, and LM prime, so LM prime and D would be collinear, and then from there, does that, okay, because AO is perpendicular to JK, and then this I think would also be perpendicular to JK, right? Is that obvious? It's probably an angle chase, right? Since DJ is equal to DK. Oh yeah, because yeah, J and K lie on the circle centered at D. Okay, so yeah, that solves it. Is that how I did it? Is that how I did it originally in my video? Maybe it is. All right, so I'm gonna write it up. It's also Romania JBMO. Okay, interesting. So they probably took it from this Olympiad. So I shouldn't have really constructed points H and F. Those are unnecessary. It's a different Varignon parallelogram. Whoops. For, yeah, points E and F, well, E and F I should construct, but I didn't need I in that other point. Okay. So, all right, I think we have enough to get started here. So, so AD is the diameter of the circle. And that means that, that means that angle AD is angle AFD is 90. All right. And let J and K be the feet of the perpendiculars. Let J and K be the feet of the altitudes from C and B to AB and AC. And then we have DE is parallel to CJ, so that means that BE is equal to EJ. And then similarly, CF is equal to FK. And then let L be the midpoint of JK. And M prime be the midpoint of EF. Someone else join? Hey, Sai, thanks for joining. So let M prime be the midpoint of EF. Whoops. Oh, what just happened there? There we go. So EDFJ is a parallelogram. Or EDFL is a parallelogram. So I'll write it like this. And FD is parallel to BK, which is parallel to EL. So ELFD is a parallelogram. And so LD passes through M prime. All right. And then it's not hard to show that LD is parallel to AO because AO is perpendicular to JK. That's well known. I've done that on my channel a few times before, so I'm not going to reprove it. And BL is also perpendicular to JK because BJKC is cyclic with center D. So I'm actually going to write that out first. So BJKC is cyclic with center D. And that means that
I
DL
think
is,
there's a property of parallelogram which implies diagonals bisect each other. So,
mhm.
so we proved ELFT is parallelogram. So uh, M dash must be the midpoint of both of the lines DL and
Exactly.
EF.
Exactly. So that's where I said here that LB passes through M prime, because I defined M prime to be the midpoint of the F. And so like you're saying, LB, that means that LB passes through M prime. So yeah, that's correct. So D, also, we have AO is perpendicular to JK. So I'll just say proven on my channel before. So that means that AO, whoops. So AO is parallel to DL, or I'll say, let me just finish this up quickly. So that means that AO is parallel to DM prime, which means that M prime equals M, which means that EM is equal to MF. All right. Any last questions before I move on to the next one? It was a fun one, even though I'd already done it before. Thanks for pointing that out, Hakan. All right. So here's the next problem. This is from 2019, so it might be a little harder. So we have a cyclic quadrilateral BFGE. China does a lot of cyclic quadrilateral problems. That's interesting. So we already have B, but let me relabel those F, G, and E. Yeah, I like how China has a lot of cyclic quad problems. It mixes it up so that they're not all just triangle problems, I guess. So DF intersects EG at C. So we have like a Bricard configuration. And FE, so FE intersects DG at H. DE. All right. So I'm going to want to label, okay, so, okay, it's not really a Bricard. We only have one part of the Bricard's configuration, but maybe the other part will be useful later. So this should be C. And I'll hide a few unnecessary things. J is the midpoint of FG. Okay. Let's call it J. The line L is the reflection of DE in CH. That's kind of random. Reflection of that line. Hold on a sec. Let me see if I can get a good diagram here. I'm not, yeah, I don't want to make it look like those lines are perpendicular. That's the thing. BE is not perpendicular to CH. But it's hard to make it. It's so weird. How do I draw it? There we go. That doesn't look perpendicular. All right. So I'm going to reflect DE in the line CH. Where's my reflect tool? There we go. So I guess it's probably worth labeling this point right here. It intersects GF at I. Oh boy, so that intersection is kind of far away. Let's see if I can fix that a little bit. This is kind of an ugly diagram, but let's see if I can make it better. So if I draw something like this, let's say, it's not so bad. So I would call, let me make it a little bigger. And of course, I'm going to hide some stuff later. But this point is I. Oh, it was already I got lucky. We want to show CH, CJ. Oh, I forgot to call this J, I guess. We want to show CJ, H, and I are cyclic. All right. Oops. Let me, yeah, but the thing is, yeah, we want part of it, of this. Let me just draw, okay, so I'll hide everything other than the portion between A and C. And then I want to show that that line is the reflection. So maybe I'll just draw this portion of the line. There we go. But I do want to, yeah, I need to draw that. Okay. This is a weird diagram. I wonder if it's worth just extending DE just so we can get the Bricard configuration. Let me draw the center of the circle just for the heck of it. So the circle is called C. So let O be the center of C. So OJ is perpendicular to FG. Let me check the problem's true. So we want to show CJ. Yep, it's true. So we need to use that. This line is the reflection of DE over CH. So basically, that's the same as saying angle EBC is angle ABI. Interesting. Okay. So yeah, I wonder how to take advantage of that. Maybe this feels very projective. So we could try to show angle CJI as angle CHI. Yeah, what can we say about how I is constructed? Maybe it's better to start with the circumcircle of CJH and let it meet it at I. I'm not sure. Is triangle CBE similar to IAB? It looks like it could be. Let's check it out. So that's 10 degrees, and this is 13 degrees, so they're not similar. Yeah, this reflection condition is weird. I don't know how to use it. So just for the heck of it, I'm going to label this point just so we can get like a Bricard's configuration. So LH is perpendicular to CO. I don't know if that helps. Let's try. What can we say about this circle? Does it concur at this? Does it pass through this point, or is that a coincidence? I would think that would be a coincidence. Yeah, it's a coincidence. If we draw the circle again, what does it mean for a circle to pass through the midpoint of a segment like this? Can we say anything about that? This looks hard. So I wonder if also, so B, E, D, B, and L are in harmonic conjugation. Huh. Actually, you know what? I wonder if we can use, so B, E, these 4 points are in harmonic conjugation. I wonder if by reflecting it, we can somehow get something similar.
I think we can use median of CDE, median of vertex C.
We can do something with Simedians. So, yeah. Okay, so CJ is the median of CFJ, right? So maybe, I don't think AC is a Simedian.
Now we draw median of CDE. Then we move the angle.
Okay, so if M is the midpoint of BE, for example, you're saying like we could draw CM?
Yeah.
So yeah.
Problem is reduced to proving CME equals to BHI.
Okay, so it's CME equals BHI. That's interesting.
Yeah, maybe they are similar. Yeah, they are similar.
Hold on a sec. BHI.
If we can prove they are similar, we are done, and they must be.
Really? Okay, so I'm just trying to think. Wait, CME and BHI, those, CMB and BHI. Okay. Is B the orthocenter of CMI? Let's see. No. That's interesting. So that, yeah, that's 11 degrees. That should also be 11. So how did you get that solves the problem?
We know that CJI equals to CMD. And we want to prove that it equals to CHI. We do 180 minus.
180 minus. That is a nice trick. Yeah, that seems a lot easier to prove, that triangle CMB is similar to BHI. So that would be a spiral similarity. That's the same as saying that BHM is similar to BCI, right? I don't know if that's better or worse than the other way, or the same. But yeah, wait, BHM, we want to show is similar to BCI. We know that one of the angles is the same because of the reflection. So, interesting. So yeah, you see what I'm saying? If BHM is similar to CBI, then by spiral similarities, BCM is similar to BHI. All right. So really, we know that one of the two angles is the same, right? We know that angle MBH is CBI due to the reflection. So we kind of have to show, that MB over BC.
Could you repeat again what triangles you find similar?
Yeah, we want to show MBH is similar to CBI. So maybe I could actually, I don't use this very often, but yeah, we want to show those two triangles are similar. And we know one of the angles is equal because of this reflection. We know angle MBH is CBI. So or we could do it the way Serdar said and show CBM is similar to HBI. Yeah, either way.
Can you delete the blue triangles?
Yeah, no, sorry, but yeah. Okay. So maybe we could somehow show there's similar parts of similar triangles. So I wonder if triangle CBD is similar to CBI. Not sure about that. CBD and CBI. So let's check that. It's 50 degrees and they're very close, but not the same. Okay. So I don't think that'll work. So yeah, let's see. So CMBC, it's probably easiest to show that angle CMB is AHI, I would guess. So CMB, that's like the angle that a median makes. So can we somehow, is H the midpoint of AC? No. So maybe we could make H the midpoint something.
Are BK and DL equal?
BK and DF?
DL.
Oh, BK and DL, I'm sorry.
Yeah.
BK and DL, you were asking
EL.
EL. BK and EL?
No, B. It's B. Yeah, that point.
BK and BL. Oh,
Yeah.
it looks like they're equal, yeah. Sorry about that. Oh, no, but not when I'm, yeah, it's close though. All right. So yeah, I feel like we're on a good track. But yeah, I feel like it's not going to be that easy to make H the midpoint of something, but I'm not sure. Let's see. Yeah, I think I could probably erase BK. I don't know if I want to erase BL, but I could probably erase BK. So BA is an angle bisector. I don't know if that really does much. But yeah, it's proving those similar triangles. That is the key, it looks like. I don't think this is true, but I'll just check it. Yeah, there's no way that's true. I wonder if this is the midpoint of this arc right here. No, it's close, but if I move it around, it's not. Can we use ratios? Maybe. So yeah, we could like maybe try to show BM over BC is BH over BI. Yeah, how do we get BI? That's the hard part. Yeah, I'd really like to get H as the midpoint of something. Check something else.
Maybe we can draw parallel from A to HI.
Okay, hold on one sec. So like that?
No, parallel.
Oh, the parallel. Okay.
And let it meet BK.
Okay. Whoops. So basically,
Let CM meet AN. I am trying to move the angles.
okay. So CM, we want to see what.
AN.
Okay. We call that P. So does that give like a different cyclic quadrilateral?
We have to prove that PM, BA are cyclic. After that, we are done.
Yeah, I think it's CBPM, right? Yeah.
No, it's true, but PM, BA are also cyclic.
Ah, interesting.
This can be power of point from C maybe.
So do you think you've solved it? Do you think you could, or do you think you know how to do the power of a point, or that's sort of an idea you had?
It's an idea. If we can prove that, we are done.
Okay. Because yeah, if this is cyclic, does it obviously follow that this is cyclic?
Yeah, because of the reflection and angles.
Ah, okay. So we need to show. So basically, yeah, we once we so yeah, because we don't need point N to define.
Yeah, actually, we don't need. I see now.
Yeah. So yeah, I'm going to hide N for now. I don't know if we're going to want to add it back in later. But yeah, so AP is parallel to IH, right? And you want to show that ABMP is cyclic. Okay. Is it also tangent? I doubt it is, but oh, it kind of looks tangent. Let's see if is that really true? I think it's tangent. Isn't that weird? So maybe since it's tangent, maybe there's some trick with homotheties or something. It's not what I would expect. So if that's true, that it's actually tangent, trying to think maybe how we could take advantage of that. So if we let AM and AB meet the circle, that's so weird.
Is AL tangent to circumcircle?
It is what?
The main circle. AL.
Let's see. Yeah, I think it might be.
And it is easy from power of point. Then we are done. Above.
Yeah, so LG times LF is LE times LD. We want to show.
We know that L, B, E, D are harmonic. So LE multiplied by LD equals to LB multiplied by LM.
That's right.
We know
about that property.
But we have to prove that LA is tangent.
Yeah, but if we draw, so we have LA squared is LE times LB, which is LB times LM. So we know LA is tangent to the circumcircle of MAB. Yeah, so basically we know, I guess it all depends how we define things, but like, for example, if I hide P for now, I'm going to add it back, but basically we know LA is tangent to both of those circles, right? So we need to show that parallel and AM meet. So yeah, if we let this, like, what if we define P to be where CM meets that circle? And we want to show that PA is parallel. So yeah, if we draw it like this, we want to show that PA is parallel to HI. Oops. Actually, we know that QR is parallel. I don't know if QR is really that helpful, but. And yeah, we have angle DAM is EAB. I don't know if that does anything. Is P the orthocenter of CAB? No. I like this strategy though. Yeah, EAB is DAM. Should be. Yeah. All right. Actually, so could we try to show, we want to show PA is parallel to IH. Yeah, that's not that easy to show PA is parallel to IH. We could try to show the angle between PA and MB is equal to the angle between IH and QR. I don't know how much that helps.
I think we must focus on I. We couldn't use very well.
Yeah, we have to use that I lies on FG. I think that's what's hard. Because yeah, like, what if instead of F, what if it was like this point? We need to use that it lies on FG. Maybe we could project, because these points are in harmonic conjugation. So if we project them through I onto AC, we would get B. We could label this point H. Let me draw IB. Is there anything special about IB? Not that I see right now. This is really random, but let me see if S is the midpoint of DF. No. Yeah, I'm trying to project through I, or yeah, somehow use projective geometry. It's kind of my strategy. It's just that I can't get ID to be anything special. Maybe LA is equal to LI? No. We could try projecting through G. So or F. Is CBD similar to CIB? No. Yeah, the key is using that I lies on FG. There's got to be a way to do that.
If the circles are really tangent, then RF must be parallel to MB.
RF and MB? Or RQ is
Sorry,
parallel.
RQ and MB.
Yeah, RQ and MB are parallel because yeah, the circles are tangent, and yeah, that's true.
Yeah. So how did you prove them as tangent? Like it, you drew the circle and moved the diagram. And I was like, whoa,
Yeah,
this shit is unreal. Like out of the whole, we found these circles are tangent
yeah.
and magical construction point M.
Mm-hmm. So B, E, B, and L are in harmonic conjugation. So have you seen this configuration before? Like we have this triangle, and then this Chevian, and then we see where F and G meets the E at L. Yeah, whenever you have this kind of configuration, so D, E, B, and L are in harmonic conjugation. I'm not sure if so that I've shown that on my channel before. I think it's my second video on projective geometry. Once you know that D, B, E, and L are in harmonic conjugation, then if M is the midpoint of DE, there's another property, and I think I've proven this before, but it's that if those 4 points are in harmonic conjugation and M is the midpoint of DE, then LE times LD is LB times LM. So if we drew the tangent to just one of, let's say we just drew the tangent to the big circle and we let it meet the yeah, so LE times LD is LA squared, which is LB times LM. So yeah, both the circles are tangent.
Know that A is on CH, we must use polarity, I think.
We have
It
to
is
use
not obvious A is on CH.
like if you draw the tangent from L to the circle, you'd have to show that
Yeah.
A lies on CH. So so that's kind of like saying A lies on the polar L, or A or yeah, basically we'd want to show that C lies on the polar of L. And yeah, that's Bricard's, right? Right, let's see. Yeah. So yeah, HL is the polar of C, and CH is the polar of L. So yeah, you have to use some. There's actually a lot that goes into this. All right. But yeah, we still have to use point I. Maybe we could show triangle GBI is similar to something. Let's see. So does BC bisect FBG? I would be maybe a little surprised. Yeah, that's not true. Is there some other circle that I lies on? I don't know if it's I think it's probably just, oh wait, I would be very surprised if that actually passed through that intersection point. Yeah. Oh, hey to Bayou, thanks for joining us. I'm not sure if you joined how much earlier you joined, but yeah, so we're on the second problem. It looks pretty tricky, and it's from the China Girls Math Olympiad.
Maybe we come back later because
Okay.
I have no idea. No.
Yeah, it looks hard. All right, so I'll come back to this one later. All right, here's another one from 2019. This one, I'm not sure how hard this one is. It's another cyclic quadrilateral problem. China has a lot of those cyclic quad problems. So I'll let O be the center. Oops. Lines tangent to O at A and B intersect at L. So how do we want to draw this? Just like, oops. Draw the tangents. They intersect at L. Okay. M is the midpoint of AB. The line through D and parallel to CM intersects the this looks hard, intersects the circumcircle of CDL. There's no way those all concur. Yeah, there we go. So let's see if I can make this look a little better. Okay, so kind of something like that. So this would be point F. CF intersects DM at K. Let me use segment instead. And intersects the circle at E. Oops. Maybe it's not a super complicated configuration. Let's do something like that. So it intersects the circle at E. We want to show EK is equal to DK. That's kind of interesting. Okay, so DF is parallel to CM. What if I drew I don't know, something like this? Just trying to make it look nice. I kind of like that. So yeah, OM and L are linear. It's interesting. So that's equivalent to saying that OK is parallel to E. I'm sorry, OK is perpendicular to EB. So maybe it's worth drawing that. don't know if it's worth using Simedians. Maybe let LD meet the circle at a point. Can I draw DL? Yeah. I guess that might help us just use stuff about Simedians, right? So all right. So we want to use DE as parallel to CM. So maybe it's also worth drawing CO. I don't know. Because CM is a median, and DM is also a median. Yeah. So yeah, we have a couple similar triangles here. I think DMB is similar to DAL. You know what? Okay, so one thing we could do, we could try to show angle DKC is twice angle DEC. And DKC, maybe, I wonder if GH is parallel to AB. Let's see. I think it is. Is that obvious? Yeah, that's obvious because of facts about medians. So angle DKC, we want to show, I mean, basically we want to show arc EH is equal to arc DC. Which is the same as showing ED is parallel to CH. Yeah, there's a lot of equivalences here. So let's see, arc EH, that's arc EA plus arc AH, which is arc EA plus arc GB. So that's kind of the same as saying that this angle I think it's the same as saying that this angle is equal to that angle. Let me check this. So 39.5. Yeah, they're both. But so it's the same as saying that GD bisects EGC, I think, actually. Oh, not necessarily, actually. No, we want to show, since GH is parallel to IM, DIME is cyclic by an angle chase. Ah, okay. I think we've solved it then. I don't know where I use the parallel condition though. DMIE is cyclic. Is it obvious that DMIE is cyclic by an angle chase? Because DEG is equal to angle DM. Well, yeah. Okay. So EDM is EDH. It's 180 minus EGH, which is 180 minus IGH, which is angle GIM. Oh, because yeah, you're right. Because since GH is parallel to IM. Wait, I don't even know where I use that F is. Could F be like any point? Let me think about this. This is so weird. I don't even see where we use that F. The DF is parallel. What if I'm just going to really quickly try a different point. Yeah, it does have to be, DF does have to be parallel to CM. So I'm not sure. Okay, so I'm going to start writing up stuff and then see what I run into. So basically, if we can show, if we can show that, I'm just trying to. If we can show arc EH is equal to arc CD, then by symmetry that solves the problem, right? So we have arc EH is equal to arc EA plus arc AH, which is equal to arc EA plus arc GB. So I'm skipping a couple steps here, but I'm going to fill it in later. Which is equal to twice angle GIB. We should use L, C, D, and F are cyclic. Yeah, I don't even know. So yeah, so for now I'm just writing this stuff out. Then you showed that angle GIB is angle EDH, right? So because you showed that was cyclic. And twice angle EDH is equal to arc. Oh, I think we just went in a circle. We need to show arc EH is arc CD. Yeah. Yeah, my bad. We need to show angle GIB is equal to. We need to show GIB is DGC, I think. the intersection of the circle with CL and BF. Hold on just a sec. Here we go. En equals GJ. Is that an angle chase? Guessing probably it is. I wonder if AG is parallel to EH. Let's see. No. But En is equal to GJ. That's what Hakan says. Whoops. So I wonder. So then I think then the problem is equivalent to showing Bn is parallel to CB. No, it's not true. See, En is equal to GJ. I'm going to delete this for now. Move it back here. CM is parallel to BF. Yeah, I've been trying to use that. I'm not sure how. So yeah, we want to show EDH is DGC. So I'm interested. So Hakan, you said En is equal to GJ. How did you get that? I feel like that's might help a lot with. How did you get that En is equal to GJ? Because LCF is equal to okay. Because it's half the difference. Okay. I think that. So I mean, really, that would be true with any point on the circle, right? Even if it wasn't F. So if we had like something like this, that arc would be the same. So, Okay, so that doesn't use that they're parallel. But I wonder, so one way we could use it is so angle BCL is then, hold on a sec. I extend CM to meet ABCD. Yes. Oh, my bad. Here we go. So is QJ. So QJ is parallel to AB, and so is GH. Also, CD equals QN. Yeah, that's true. Maybe that'll help. Or QINN, no, QINN. What? Maybe LQNN, no. No three of these points are linear. So yeah, EN is equal to GJ, and QN is equal to CB. Can we subtract the two? So EN and QN. So the difference between those arcs is QE. And the difference between the other two would be the difference between GJ, CD, would be this angle. So arc QE, so I think that means that angle MCE is CLB, maybe. Not so sure about that. Okay. Yeah. So if that's true, that means arc, oh, because arc CD is equal to arc PF, yeah. They're parallel. So yeah, maybe that helps. There's so much similar information here. It's tricky. So arc EQ. I'm starting to get some ideas here. So we want to show arc CD is equal to arc EH, and EH is EQ plus QH, which is EQ plus GJ, which is this angle right here. Ultimately that angle. Oh, but now I'm just going in circles. Okay, how did you solve it? Oh, sorry. We want to show En equals QH. How does that solve it? We wanted to show CD is equal to EH, that's right. But CD is equal to NQ. Okay, so we want to show NQ is equal to EH, and that's the same as saying En. Ah, okay. All right. Yeah. So yeah, we want to show NQ equals EH. So yeah, it's equivalent to EQ is parallel to NH. I agree with that. And that's the same as saying En equals QH. I agree with that. And En equals GJ. How do we know En equals GJ? Because GH is parallel to QJ. So how do we know En equals GJ? You might have already mentioned. Oh, I think you already mentioned this. Yeah, because okay. So yeah. All right. Very nice. It's just like a whole bunch of equal arcs over and over. So where did we use that M was the midpoint? Oh, I think it's just Simedian stuff that where we use that somewhere. Is there anything I can erase? I don't think I need point I, right? Yeah, okay. So how did I define Q? Oh, like this. Can I finish the problem after? Yeah, once CD is equal to EH, everything is like symmetric. So yeah, it's all good. Okay, so I'm just thinking how to start with this. So let CM intersect. We'll just say the circle O at Q. Yeah, we're going to want to label a whole bunch of points. I'll just write a whole bunch of things right here. So let CM intersect O at Q. And then CL intersect O at J. And then DL intersect O at G. And is that everything? GH, Q, oh, H. I have to add H. Okay, so by the Simedian theorem, angle ACM is equal to angle so yeah. Angle ACM equals angle ACQ equal to angle BCJ, so that means that QJ is parallel to AB. And then also, similarly, we'll just say also we have angle B BH angle BDM equals angle EDG, and that means that GH is parallel to AB. Okay. So now we can do the arcs like I mentioned. So so first we're going to try to show EN is equal to QH. Okay, so first I'm going to show EN is equal to GJ. So so we have arc EN. Yeah, I'm trying to think the best. So first of all, we have angle DFC is equal to angle DLC, and we have angle DFC is half of arc EN minus CD. All right. And we also have angle DLC. That's half of arc CD minus GJ. Put some parentheses here. I forgot to do that before. Hold on a second. I wonder if we're missing something. So basically, yeah, so this implies EN is equal to GJ. All right. And once we know that, we also know GJ is equal to QH. We'll just write that here. That's because DFC and DLC are equal here. So EN is equal to QH. And where did we go from there? So if EN is QH, then that means EH is QN. Okay, actually I just showed EN as QH. So we wanted to show CD was EH. How did we go from there? So how did we show that CD is equal to EH? Yeah, I'm just thinking through it again. We wanted to show CD as EH, but CD is equal to NQ. Ah, okay. So we have DF is here's where we use the parallelism. So DF is parallel to CM. That means that CD is equal to QN. All right, so okay, so how do we combine those two? So QN and QH. Okay, so CD is equal to QN, which is QE plus EN. Is equal to, okay, so this solves it. So that's QE plus EN, which is QE plus QH. Which is EH. All right, so this overlaps the figure. Maybe I'll just add in, just do this just for the heck of it. And so if arc CD is equal to arc EH, then from there it's pretty clear that EKD is isosceles, right? So I'll just write it out. So angle DEK is equal to half of arc CD equal to half of arc EH, which is equal to angle DEK, and this is angle EDK. And that means that EK is equal to DK. Nice solution. Yeah, it's like a parallel chase. I feel like there's a couple problems like this that I've done before where it's like you're chasing parallel chords in a circle.